In this video, I am going to be talking about the penetrating ability of alpha, beta, and gamma radiation. The penetrating ability is how able a radioactive substance is to be absorbed through its materials. The penetrating ability differs in each particle, and it depends on the size of the radioactive particle. Alpha particles are the biggest particles, and they are the least penetrating, and they can only travel a few centimeters in air before being easily stopped by a few pieces of paper. Beta particles are smaller than alpha particles, but bigger than gamma rays, and they pass easily through air and paper, but they are stopped by aluminium foil. Gamma rays have no mass, and they are the most penetrating, and so they are difficult to stop and require many centimeters of concrete, lead, or other heavy shielding to stop them passing through. The bigger the size of the particle, the more chance it will have to collide with atoms of the material, and as a result, the collision stops the particle going through the material. An electron is knocked off an atom when either a particle or ray collides with a material. As a result, the atom becomes an ion. As the penetrating ability increases, the ionizing ability decreases. This explains why alpha particles, which are the least penetrating, are the most ionizing, and why gamma rays, which are the most penetrating, are the least ionizing. Just a single thin sheet of paper with a few centimeters of air can easily stop alpha particles from being absorbed. The alpha particles that travel through air collide with molecules of both nitrogen and oxygen. Each time the particles collide with either of the molecules, they lose some of their energy in ionizing the air molecule until all of their energy is wasted and are absorbed. Also, the molecules found in a piece of paper are closer together than the molecules found in the air. So, alpha particles can't penetrate or be absorbed through paper as much as in air. Beta particles travel relatively faster than alpha particles. They carry less charge, and so they don't come into contact with the atoms and molecules of their material as much compared to alpha particles. This allows for beta particles to travel further distances than alpha particles and be absorbed through materials more easily. Beta particles can be stopped by a few millimeters of aluminium, but they can easily pass through paper. Gamma rays are the most penetrating out of the three particles. They possess high energetic waves, and they are hardly ionizing. Several centimeters of lead or concrete are needed to absorb the high levels of gamma rays. In terms of hazards within radiation, alpha particles are considered to be the most hazardous form of radiation inside the body, as they are the most ionizing and can be easily absorbed by the cells of the body. However, there is an extremely small chance of this happening, as alpha particles are the least penetrating. Beta and gamma radiation are considered to not be as hazardous as alpha particles inside the body. This is because there is a small chance for them to be absorbed by the cells of the body, and they are more penetrating, so they will just pass right through. However, beta and gamma radiation are the most hazardous source of radiation outside the body, because the cells inside the body can be severely damaged if they penetrate through the skin. Thank you for listening.